Okay, so we are recording. Today we're going to have a really nice challenge, but it's currently undeployed. So before I deploy it and add a flag to it, so people can look for the flag, and actually the first guy to or first person to get the flag is going to get an award at the end of this bootcamp. So while I do that, Ahmed's going to explain a bit about Git and why it's important and how can we upload our projects that we have built so far into Git. You can go ahead, Ahmed.
All right, thank you everyone. Thank you Adam for the quick intro. Now for like the 10 minutes until Adham is ready, I'll give a quick intro about Git. We have mentioned it a couple of times in our SOC group. And by the way, if you're not in the SOC group or the Society of Cybersecurity at AOS, please message one of us, either me, Adham, or Omar Safat, or any of the team to get the link. So Git, what is Git? If you remember last time when we had the SOC Voices initiative, we explained that Git is not GitHub and GitHub is not Git. These are two different things, but they're usually used together. So the basic idea of Git is controlling your version. We call it a version control system or something similar. So let's take a quick intro here. Say, for example, my code is in this current state, C1 or commit 1. Commit is like, we can think of it as like the current state of your code, okay? Or like a milestone or label in your code. So first of all, say you've written some code and then you wanna save the code or save the current state of the code. You have finished or like reached a milestone. So you can, first command we'll learn is like git commit. As you can see now, this is the commit tree, what we call a commit tree. The commit tree has increased by 1. So now the current state of our code is at C2 or commit 2. All right. Say, for example, you did more changes, you have written more code, you added a new feature to your website, you make a new commit. Now, for example, oops, I messed up. I want to roll back to commit 1 or commit 2. All right. So the first task was, or the first command, sorry, was git commit. The second one is git reset. All right. And we need to specify where do you want to go. So currently my pointer is at C3. The current pointer, which is denoted by the star, not main. Star is something, main is another thing. My star is what we call the head, which is like the pointer of the current state, which currently points to C3 or commit 3. So I will type here head, and for example, if I want to go back one step, I will do tilde, or some people use the caret symbol. Okay, there is a small difference between them. I usually prefer the tilde. So if I do this and go and hit enter, you see now I have rolled back to C2, and behind the scenes, the Git algorithms will use some like magic in order to change all of your source code, your files and everything. It will delete lines, it will add lines in order to go back to the previous state in C2. Okay, now let's, for example, go back to C3, git reset, and I can type the name of the commit, C3. All right, one more time, git reset. And this time, instead of like using head tilde to go back one step, I can go back 2 steps. Head tilde 2. If I specify nothing, this is like exactly equivalent to tilde 1. If I specify, for example, 2, I'll go back 2 steps. So let's see. I've jumped 2 steps from C3 to C2 and then to C1. Now, if I, for example, roll back again to the latest version, which is C3, for example, I can directly, instead of like using what we call relative, I don't like remember the exact name, relative something, we can, for example, if anyone, by the way, knows the exact name, I can't think of it right now, please share in the comments. So instead of using the relative notation here, which is like go back 1 or 2 steps, we can directly reset to a specific relative addressing, probably, I'm not sure, Muhammad. Okay, we can like easily roll back to any commit using the hash code or the ID of the commit. So I can say, for example, C0, instead of like doing the math and saying, okay, head tilde 4 or 5, I can directly give the ID C0. All right. Now we're done with commit, we're done with reset. Let's try, for example, something more interesting, which is branching, which is like one of the most, if not the most important thing about Git and GitHub. But before that, I will share this link with you, and I want you to finish level 1 and 2, not 1 and 2, only 1 for now, yourselves, and let me know when you're done by like maybe raising your hand, a thumbs up, or commenting the message. Make sure you quickly skim through those explanations. They're amazing. This website, by the way, was written and designed by a software engineer at Instagram. So I think he's a pro. Okay, I'll give you guys 3 minutes from now, and then I'll show the solution. Anyone done, guys? How is the progress? Can I get an update? No, first one, Muhammad. Okay, amazing, Tawfiq. Good job, Rashad. Should be straightforward. Muhammad is done. Okay, I'll give a few more seconds. All right. طيب. Now, after we have, 1 second, let me go back to the sandbox one. Okay, good. Now the solution for the task was straightforward, just like literally git commit to make a new change in your data or in your project. Now after that, say for example you're working alone or in a team, you decided to work on a new feature or maybe fix a new bug that you have found, but you don't want to like mess up with the original or the main version of your code. So you want to, well, like what you'll ideally do if you don't know Git, you will copy your project and paste it in like a safe, like name it project 2 or project backup, and then do all of the changes and then like somehow merge the two projects together. All right. But like that's a lot of work and it's like it's not efficient at all. Instead, we can use Git and a tool in Git called branching. So let me show you. Say, for example, I'll be doing Git branch, and then the name of the branch, I'll call it feed for feature, and I hit enter. As you can see now, my main branch is there. That's the default one. And I have just created a new branch called feature. Now let me do what we call check out a branch. So let's enable that branch. So I'll do get check out, and then the name of the branch is feature. Okay, and in a second I'll show you like a quick way of doing both steps together, creating a branch and switching to that new branch directly. So now if I make a new commit, get commit, as you can see, let's make one more commit, for example. As you can see now, what is actually changing or being modified is the feature branch. So the main branch or the original code is not being touched. All right. So if I like messed up something, if I broke a code or like I broke an API or something, nothing will be affected in the main branch. Usually the main branch is what people or companies use for production or deployment. So that's the version of the code here in main that will be used by the clients. All right. Now let's, for example, use get check out main. As you can see now, my head, which is denoted by the star, is pointing to the main. Now, if I make a commit here on main, do you see what is happening? Now I have two different branches and they're like not related to each other, okay? Except for like at C2. That's the common point between the two branches. And then from that point, they branched out. So whatever happens in main will not affect feature, and whatever happens in feature will not affect main. Later, maybe, okay, say for example, I'll check out again to feature, get check out feature, and then I'll make a new commit, one more last one. All right, now خلاص, I'm done with the feature. I created it, I tested it, everything looks good. I would like to merge it back to main so the people or the clients can see the new feature and use it. So now I'll do get check out. So remember the commands that we're using, to sum up quickly, is commit to make a new commit or make a new update in our code. We're also using check out to change between the branches, and we have used branch here. As you can see, get branch feature to make a new branch, and now we'll take merge. So let's now get check out to main. All right, so my star or my pointer is pointing at main. All right, now I would like to merge the two branches together. So I want to add the changes made or the commits made in feature. I want to add it to the main branch. So I will simply do get merge main. Let's see what will happen. Branch already up to date. 1 second. Am I on main? Oh, sorry. Get merge feature, not main. I am on main. My star or my head is at main, but I would like to merge feature. So let's hit enter. You see what happened? Now C7 is the combination of both C6 and C5. Now let me open a text editor here quickly. And say, for example, you have file 1, which has hello, my name is Ahmed. All right. And I have file 2, which has hello, my name is Omar, for example. All right. File 1 is f1.txt and file 2 is, for example, f2.txt. Now, if I want to merge both changes, like this is in one branch and that is in another branch, I want to merge both. What do you think would the result be? It will simply be adding both files together in the new branch. Oh, you don't see? Okay, I'm sorry. Thank you, Muhammad, for letting me know. Let me share again 1 second. Okay, do you see the screen now?
Yeah.
All right, amazing. So now I was saying this. Say, for example, you have two files. File file1, and we also do have file2.txt. So file1 has this line, hi, my name is Ahmed, and file2 has that line. All right. Now, what do you think will happen when I try to merge both changes together? So that's in a specific branch, say the feature branch, and this is another branch, say the main branch. When Git tries to merge both, it will simply create two files, okay? Because you don't have any conflicts here. What if, for example, my changes are as follow? Both branches are modifying the same branch, okay, or the same file, sorry, and I'm trying to think of a good example. Okay, I have an idea. Okay, say we're modifying the same file, okay? And I'm trying to merge both changes. The first file has two lines, hi, my name is Ahmed, and the second line is empty. On the second branch, the first line is empty, but the second line has hello, my name is Omar. So when I try to merge them, we don't have any conflicts again. So Git will simply take both lines. It will take this one, and it will take this one. So both changes could be merged together easily. But the hard part is when, for example, you have conflicts, like here. Hi, my name is Ahmed, and hello, my name is Umar. Should we take hi or hello? Should we take Ahmed or Umar? Both are in the same line. In that case, Git will tell you, I don't know what to do exactly. I'll just leave it for you to decide. And you can fix it using Git commands, or if you're using VS Code or any other IDE, you can easily do it. All right. Now, let me close this and share again. Is it this one or that one? Share. All right. Okay. So we're back to the point. Do you see the screen? Yep. Here. So the point is, I was working on feature here on this branch, and I had the main branch, which was at C5. When I merged both together, I just simply merged the two files or the two changes into one branch. Now, if I want to continue working, I will continue working from main. Halas feature is done. It's like you can think of it as dead. I won't be using it again. So git commit. Now all of the new updates will be applied to main directly. All right, I think someone raised his hand.
Yeah, I raised my hand. I just had a question about when you were in the text file and you
Yeah.
created the two text files with file1.txt, where the first line had hi, my name. The first file had hi, my name is Ahmed as number one, and the second one was blank. But in the other file, the first line was blank, and the second line you had written something, and you said it is in the conflict, right? When you do git merge. Right, how is it not known that, how is it know that it is not a conflict? Because doesn't it see that in one of the files there is something written on the first line, in the other file there is still that one written on the first file, right?
Yeah, but those are two different distinct files. Do you get my point? So those are like two different files, and changing one will not affect the other. Think of it like you have two Python files or like two PDFs, and changing one will not affect the other. So if you want to merge both, you just simply add both to your final directory or your final project
I
file.
mean, like the file's name was the same, right? It was file1.txt.
Oh, they were the same file and they were modifying the same line or two different lines?
They were modifying two different lines, but yeah.
Yeah, so two different lines. So the first modification was modifying the upper half of the file. The other one was modifying the lower half of the file. So merging both will not affect anything.
Okay, so even if it sees that in the upper half of the file has the line and the one dot, and
Yeah, it will just like add them. Now it might not make much sense here now, maybe when I open VS Code in a minute, I think it will make much more sense when I like show you an actual example. Here I'm just like in this graph, I'm just showing you commits without any files.
Okay.
But like
cool.
soon I'll show you on VS Code how to do it with files. I think it'll make much more sense.
Oh, okay, that's fair.
All right, guys, any other questions before we continue? Please feel free. Muhammad is asking, so when it complains, does it still merge or does it cancel? Neither of the above. It doesn't merge and it doesn't cancel. It will pause, wait for you until like you fix the conflicts, and how to do that exactly, that will come soon. And then after, when you're done fixing the conflicts, you can like use a special git command. Let me show it to you now in a second. It will be git. Is it zoomed in enough, by the way, or should I zoom more? Is this good? Can I have an idea? Okay, it's good. No. Now, for example, say you ran like git merge, but like it paused. When you're done fixing the conflicts, you will say git merge -- continue. Okay, you'll just like continue. If you want to cancel for whatever reason, for example, you can abort, or you can, for example, skip. Each option will give you like different results. But I just like diverged for a second. Anyway, now please guys, the same website, the same link, I'll reshare it again for people who came a bit late. Please start doing challenge 2. I'll give you 2 minutes from now. Let me just share it again.
And we're done with the deployment, by the way.
All right, amazing. Let's like 2 minutes if you don't mind. They'll just solve the.
Yeah, sure. This is actually very, very important.
Thank you. And while people are working on it, please ask questions if you have any. On the chat, open your mic. How is the progress, guys? Amazing. Had is done, Timothy is done, Yusuf Rashid is done, Tawfiq. Okay, so is it straightforward? So this is just like the basics and the essence of Git branching. Later in like future lessons, we'll make another lesson for Git and GitHub. We'll learn more about rebasing. That's another way of branching. Sorry, another way of merging. So there are like two schools. Some people prefer like merging. Some people prefer rebasing. But that's for like a different topic. All right, by that, I would like to conclude today's introduction to Git. Thank you, Adham, for giving me the opportunity, and the mic is yours.
Thank you, Ahmed. Thank you, Ahmed, for covering up. Now we have the
Pleasure.
servers deployed for the task, for the challenge, and let me actually close anything that gives a hint about how do you solve it. And I'm going to show you, it's very, very interesting. I spent like 7 hours today building the server for that protocol. So let's share our screen. No, I want to just share Google Chrome. Yes. Okay. So actually, before that, I want to show you something. So yesterday we said that Python is cross-platform, right? Okay. So why is that? So let's think like engineers more and like get a little bit in depth with Python. Python is open source. Okay. So Python itself is the specification. It is like defined as pseudocode or like as concepts in something we call PEPs. Okay, so Python PEP, not Pep Guardiola, no. Yes, so no, let's see, Python enhancement proposals. And these proposals, they are done by a committee, okay? And that committee decides how Python should look like, okay? The syntax, the API, how can you interact with like different features of Python. And then after the standard or the concept, the idea of Python, we have another thing, which is the actual implementation, okay? And that's where we find that there's actually so many Pythons. It's not just one Python command. So for example, look, there's here, as an example, the Python command, okay? So this document is describing how should the Python command look like. And they're talking about all of the things that we find confusing, Python 2, Python 3, whatever. We have tons of these stuff. Like, for example, this is about type hinting. So like the ability to give or hint about a type. So like you can do that kind of, where is it? That's the other languages. So they're looking at features in other languages and proposing that we include them in Python, that kind of thing. Proposals. Now the implementations, so we can look at actually Python implementations. And you'll find this a lot in technology. Okay, I'm speaking quickly because we need to get to the task. Python implementations. Let's see, alternative Python implementation. And there's plenty of these. So if you look at this, there is something like PyPy, okay, which is a different implementation written like the internals is different. It's like that, the exact same syntax, but the internals or how it works, how it interprets your code, how the mechanisms it used for that are different, and that makes it faster in some cases. For example, PyPy, and we can look at the project for that. It's different. It's not Python.org. It's something else. And they're like doing benchmarks on how fast it compares to Python. Iron Python, for example, that's a different one. Okay, that allows you to use .NET or like Windows libraries in your Python code, so you can import them just like as you would in a .NET language like C# or ASP. Jython, that allows you to interact with Java using Python, and it's exactly the same Python code. So this is Python code that you can, so using JSON, you can import the Python interpreter to execute Python code inside of Java, and you can do the opposite as well. You can execute Java functions inside of Python. So this is from Java in a Python. So what I'm trying to say is, do not get fixated as engineers, as someone who's now more in depth with the technology. Do not get fixated on the, I'm sorry for that. Do not get fixated on the words or the commercial names of things, and understand that it is like everything is possible. There's so many variations in these technologies. Was this loud? I'm not sure if this is canceling anything, but I have the street right behind. So do not get fixated on like the idea, okay, we have Python and that's it, and all Pythons are the same, or that's Java. And no, we have like different implementations. We have we draw a difference between the standard or the concept, the idea, and the actual implementation. And we know that different versions means something, and you know, that kind of thing. So that's the idea I wanted to show it to you. The implementation that we use, we commonly use is CPython. That's the one you get when you go to python.org, when you download it. Now, if we go here on GitHub, the one we're actually learning about, and that's why we're talking a lot about it and how important it is, we have the actual CPython documentation, okay? And I want to show you something, okay? So if we go into lib, and we go down here, we can see the entire Python standard library. So collections, email, HTML, HTTP, JSON, all of these. And we can actually look at the source code for all of these. I want to show you the part that's related to sockets, okay? So the one we were doing yesterday, okay? So, and let's see why it is cross-platform. Let's look for socket. Okay, there's here socket.py. And here we go. We have the functions. This is this is the documentation, first of all, sockets. And you can go here and look at all of these things. So I can look at, hey, here's all of the error messages you can see on Windows. These are Windows specific. And they have a mapping for these. If you scroll, it's a large file, obviously. And you can look at all of these. So accept, the function we used yesterday. It's a method inside the class socket, the one we just used yesterday, precisely. And we can see here all of the code related to that. Now, but this is still Python code. So where is the platform-dependent code that's supposedly written in C? That's like, you know, because the way you open a socket on Linux is not the same way you open a socket on Windows. So how does Python do that? Okay. So if we look up here, we can see something very interesting. This import sockets. Okay. So let me go back. I know it's a deep, it's not, I mean, an unexpected dive into like something deeper, but just it's for exposure. So like get the idea that this kind of thing exists out there. And if you want, you can look at it and you can learn more about it. So let's do this. If we go here and we go to modules, okay, these are the C extensions or the cross-platform dependent code that's embedded into Python. So you see, like they start with this underscore. If we look for socket, there's one called socket module, okay? And if you open that, here we go. This module provides an interface to Berkeley Socket IBC, and we can talk about that later on another day. And I think one of the articles I shared, it talks about this idea, and this is just the interface, or you know, the way we do socket.connect, socket.accept, socket.listen. This is very, very popular and very common. And it's called, that kind of interface is called the Berkeley Socket like convention or interface, because it was first used by the people at Berkeley. So if we go down here, we can see now, this is C code now at this point. And we can see things like, I want to show you, yeah. So here, if defined OpenBSD. So now, if not defined Linux, okay? So it's now doing conditional statements based on the operating system that's running, okay? So if there is no Linux, then I'm gonna do some stuff because now it's very platform dependent, okay? Let's see. So I wanna look at like WinSocket. Okay, so now we have some stuff that are only Windows. So like they have comments on like, this is WinSock2 or the library for Windows only. Let's look for this, winsock.h. Do we have that anywhere here? I think not, it's probably important here. But anyways, we can look at all of these and you can see now, okay, if not defined Microsoft Windows Desktop, then do that. Use Bluetooth stuff. You know, it gets pretty in-depth. This file is very, very long. Let's go all the way at the end. How many? Okay, 7K lines. 9K lines, okay? So that's what you would need if you want to write a cross-platform piece of code in C that can work whether you're on Windows, or that would compile correctly if you're on Windows or Mac or Linux or whatever. And Python have that done for us, okay? And that's why we tend to use Python in many applications, okay? And most, I mean, all languages in their standard libraries, they would have a socket implementation that does that kind of thing. But it's important to be aware of it. Okay. One thing, yesterday we mentioned the RFC, okay? And RFCs are, now first of all, is this clear, the part we just discussed? I know it's a mouthful, but let me know. Okay, okay, everyone, yes. Okay, excellent. Okay, so yesterday, thank you, Tawfiq. So yesterday we talked about RFCs, and these are requests for comments, I believe. That's the abbreviation. And these are written by the Internet Engineering Task Force. So if you're doing networking, if you're doing web development, if you're doing any kind of thing like that, again, just as we mentioned yesterday, you want to try your best to go to the most authoritative source. Okay, we have YouTube videos, we have like instructionals, we have tutorials, we have like sites like Geeks for Geeks and like W3 Schools or whatever. But no, these have a place, but at the same time, as an engineer, try your best to get familiar with the original, the authoritative official source that these people copy or get their information from. So like if I were now to develop an HTTP server, okay, and I'm preparing for what we're gonna do now, our task. So if I'm going to build an HTTP server, would I go to W3 School to teach me about how HTTP should behave? Or would I go to the actual people who developed HTTP? Okay, that's IETF. But for example, for CSS, for example, if we go to the W3C, okay, that's the World Wide Web Consortium. These are the authoritative people who define CSS, for example, and we can find the same thing for HTML. And they have these documents, these standards. If we open any one of them, so like, let's see, CSS level 2, for example, these are the authoritative standards explaining everything about this stuff. So selectors, for example, and it's a lot, okay? So it's a lot, how bad it happens. And it's all in pseudocode, because now what's nice about this concept of standard or idea and implementation is now me as a standard writer or as an organization, I just say that these or that kind of thing, it would be very nice to have. Like it would be very nice to have if we have like something like this active that or hover that allows me, and if you don't do CSS, it might not be clear, but this feature of the language will be very useful. I don't care how you do it, I don't care how you implement it, but I think if we have a language that has this kind of feature, it will be very, very massive. And the developer community is going to benefit from this. So this does like some sort of separation of concerns. The idea is on its own, developed in its own. It might be, the idea might be very ahead, just like we have in like math and engineering. So the idea, the concept is well developed, it's ahead, but we don't have, okay, so the idea is ahead, but then we have competing implementations. So now Google and their Chrome or Chromium, they're trying their best to write very efficient code that implements this specification for CSS. And I think we have one for HTML as well, and JavaScript. We can look at that as well. The ECMA, we can find the ECMAScript specification, and we can find the language specification of JavaScript and how it should behave and how it should interact with with web pages, for example. So that kind of thing. And now we have like different companies competing to do or to build better performant implementations of these things. Just like we've seen with Python, we have the idea, and we have different companies doing the implementation differently and trying to improve performance, or maybe like cover a niche that's not covering by the original specification, like we've seen like Python for Java, integration with Java, or Python with Ruby. I think there is one, but you get the idea. So now for networking, we have the same thing. We have the Internet Engineering Task Force, and they have lots of RFCs. So we can have like, I think RFC 768. I think that's UDB. Yeah, that's UDB. So, and I have that memorized for some reason because I studied it. So You have the standard for UDP. It's written in 1980. Okay, that's some really old protocol and still behaves the same. Sometimes there are revisions, there are like different versions, and we're going to look at that today in this task. It's going to give you more highlights on this. But you can see like now they're talking about how it looks like now. Now your textbook, your networking textbook is going to give you this in a nice drawing diagram, but this is where it came from originally. Other textbooks, authors, they might gain credibility by simplifying these authoritative documents, but this is where it comes from originally. And as an engineer, you need to have the know-how. And as you can see, it doesn't describe the implementation really much. It doesn't talk about this. But again, it's just about the idea, the concept. And then companies like Microsoft, like Apple, when they're writing their operating system, they implement that kind of thing, and they try to make it as performant and as optimal as possible. Companies that are like building routers, Cisco, FortiGate, building firewalls and stuff, they need to have their own UDP and like TCP and all of the protocols. They need implementations for these. How can we deal with these protocols? And they try their best to make their implementations the best possible. Okay, so now this is the TCP, and we can look at the different things. Now, what do we have in plan for you? We have something very interesting. We have this. Let me actually share with you this document. So if we go here, now we're not going to implement TCP, obviously. That's not the protocol we want to implement. I don't think we can, or anyone here can. It's beyond the scope, obviously. But now, what do we have here? We have the animal sound protocol, okay? And that's a protocol that was designed by some veteran battle-tested protocol designers, mainly me. And this protocol is, I mean, you can read about it. I'm going to give it to you. So it's going to be like, here is the specification for this protocol. And there is a running server serving this protocol, talking in this protocol. And you can read about it. It's mostly concepts that we've discussed yesterday. So like TCP, it's running over TCP. And we have a couple of features, and we can look down at different versions of this protocol and how it behaves and different errors it might give up. It's a small document. It's nothing compared to the ones made by the big boys at the IATF, obviously. And we have a bucket structure here that you can look at and see what each like part of the protocol looks like in the header of the protocol. And then your task is to build a, first of all, is everyone up to date till here? Are we good? Excellent. Excellent. So our task is to build a client, a valid client implementation of this protocol that can speak in this language and talk to one server that we have hosted to you, and basically find a flag. So by reading the specification, understanding this specification well, and trust me, it's simple. It's not going to be, it's not complex. Just go through it, read it together. And I can help you if you want, if you need clarifications. But some method here or some way after you learn how you can interact with this protocol, you'll find some flag, okay? So there's a way to extract a flag. So learn how to use the protocol first, like legitimately in a proper way. And then eventually, at some point, you'll be able to extract a flag from the server running this protocol, okay? And this flag is encrypted. You have to decrypt it. First of all, find it, and then the first person who sends it to me on WhatsApp gets the award, okay? So you can go ahead. What's the flag? The flag is a piece of text. So when you interact with this protocol, you will get responses back, okay? Once you develop a proper client. And let me actually, so let's actually show you an example of me. No, but the thing is, the board of the protocol, I want you guys to find it. Or let's not make that part of the challenge, okay? Or do you should I tell you which port it's running on, or should you find it yourself? What do you think? So there could be two challenges: scan the network and find that protocol, and then two, build the client and talk to that protocol and capture the flag. What do you think? Okay, let you guys do it. So some of you built a board scanner, so you can go ahead. I can change it. Okay. 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 So Omar is saying, okay, give them an example, and then he will change it later. Okay. Okay. Cool. So what we can do for now, let me actually stop presenting this. Show you an example. Okay. So the server it's running on. Yeah, I'll give you a range, obviously. Let's Cali. Okay, and we don't have a. Okay, cool. Wait, I'm scared. I think my history is gonna expose some of the how you get the flag. Okay, so because on Cali, okay, now we don't have history. Okay, cool. So I don't want to. I don't want to mess up disclose the solution. So now let me get the IP that it is running on. You guys should. Okay, that's the IP. Okay, and we can bing that. I think it has bings disabled. Anyways, so if we do netcat, okay, netcat just like as we have done yesterday, and the current port, Omar gave that to me. He's hosting it for us. Thank you, Omar. If we do this, I think we're connected. Let's actually do -v here so we see that we're connected. Enter. Here we go. And you can see here that it is running on AWS. It did reverse DNS resolution, so it found the name from the IP. And if we disable that using N, it's not going to do that. Yeah, it's just going to work with IPs, just like we've done yesterday. Let me zoom in. Control L. Oops. So if we do this, now we're connected to some service. Okay, and Omar is going to change it because we need to scan for this. You can do the scanning with your own script that you have found, or we can show you how we do it with netcat. But I don't think all netcats have. Anyways, so now if I talk to this, there's some service running here. I don't know how it speaks, what language it speaks, but I will tell you that this service is speaking in our ASP protocol, the one I just made, Animal Sound Protocol, the one I shared with you on GitHub. Okay, so let's actually put that in so you guys have access to it here. So it's in the chat. Okay, send, yes. So it's in the chat. You can look at this. But this server is speaking in our protocol. Okay. Now let's send it something. Okay, so I'm gonna send it some A's. So I get this invalid packet size. Okay. If I send now, because this protocol, this convention, this method of communication that I just made, it's designed in a certain way, okay? So I have to speak to it in the way it is designed for. And the way we know that is by doing this kind of thing, looking at this structure and trying to send it something that fits in this structure. Now you will need Python, you will need to build, or you can copy your, repurpose your client code from yesterday to build the client. Now you can have you guys can easily have a socket, a client, a TCP client using sockets, right? Now you need to send something. You need to connect to this port. You don't need to do it with netcat, although you can. But use Python because it's easier to like structure the bucket and do that kind of stuff, and send it exactly the things it's asking for. Okay. Try to build something that's similar to this and send it to this server. Okay, and I have explanations like what version looks like, what is reserved, what is a key, what's a method, what's buddy. And then once you're able to send that kind of data, that specific data, surgically, with surgical precision, every bit is correct in the right spot, you can talk to it and it will give you stuff. This protocol is useful. You can actually request animal names. So you have different methods here. and you need to know how can you send a packet or a request with a method in it, and you can look for animal sounds, and you can convert the valid animal name to the sound or that's made by that animal. It's a very useful protocol. I know it's revolutionary. But once you're able to do that, once you're able to create a backend that talks about extract something from that protocol, read this, and you have the flag. Okay? And yeah, that's it. So these are all invalid packet sizes. One thing you can do if you want is you can do like printf, okay, here, and you can do like this. So this sign or this symbol is piping. So like whatever is written here is going to get piped to that socket. So if you want to test it without Python, okay. So here you can like you can even send like hexadecimal characters, okay. But still, that's an invalid packet size. So actually, you can do it this way if you want, or the way I recommend is just do it in Python and like formulate your payload or the request, your packet, and send it, and try to automate it. Okay. So that's it. Is that clear, or am I making no sense? I think it's clear. Does it give the flag on any? No, of course not. So you need to learn how to talk to it, and then a certain method, maybe some certain structure, which is hinted in the documentation, is the one that's going to give you the flag. Okay.
Adham, the answer should be in which documentation? The README file, or we need to open another file?
Yes, that's the one I just sent. It's in the front page. So whatever we have here, this is the specification for the Animal Sound Protocol, ASP, the Reliable, Secure, and Comprehensive Protocol that I wrote, which is very useless, but yeah. So can you use your knowledge of reading specifications of sockets programming to build a client that talks to ASP? Let's see. So that's your challenge. Now, let's give you, Omar, can you run it on a different server, on a different port? Let's actually give like some instructions in case it's not clear like what we need to do. So let's do this. So here, okay, let's make this bigger. And so one, socket build or repurpose your sockets client code from yesterday. Okay. 2, which is like I think 3 lines of code or 4 lines of code. Very simple. 2, we need to send something specific to talk to this protocol according to this specification. Okay, so you have to go here and read this and try to get yourself to send. This whole thing is around how many? So this is like first byte, second byte, and like this is like 4 bytes, and then 4 bytes right after. So these are like next to each other. So that's the way we draw the diagram, but they're next to each other. So we have, so if I'm able to send in the version here, let's see, this first 4 bits, okay? So if I can send something like, and I'm going to show you, if I can send that, then I'm going to set the version or tell the protocol, the server, that I'm going to be using that kind of version. And then if I can change the key, if I can change the method, and so on and so forth. So you need to send or understand, read the specs, specification, send the right or the correct ASP request, and that's the name of the protocol, the Animal Sound Protocol, to the server. Okay, and then now once you've done point 3, it's going to be very easy. Now you need to look at the hint in the specification. I left the hint in the specification so you can know what and I don't want to spoil it. You guys